Okay, let's continue. Okay, are you still with me, guys?
Yes, okay.
Okay. So we do have another 20 minutes, maybe. Right. So just now, we learned about the equilibrium in 2D. Okay, for the rigid body. So this time we will learn about the equilibrium in 3D. Okay, for rigid body. Okay, it is same, not really same actually, but it is a bit different lah. Okay, because it is involved in 3D dimension, 3 dimension. Okay, so what you will learn for today, okay, for this lecture, the first thing is about the equilibrium condition in 3D for rigid body. It is the same as 2D, where we have to determine reaction. Okay, we have to determine reaction for the ball and socket, for example, for the touching surface, for the rough surface, for the rollers, and so on. Okay, you will learn about it. And of course, you will learn how to draw FBD for the 3D rigid body and analysis approach. And also the last one is example and exercise. Okay, so let's recap back the equilibrium system that you have learned in the previous lecture. Okay, since we do have a 3D, so meaning that we have 3 components, we have 3 axes. Okay, so we do have X, Y, and Z axis. So each of them having a component having the summation of forces, and the summation of forces must be equal to 0. So if the summation of forces is equal to 0, meaning that the system is in equilibrium. Okay, and not only that, if the rigid body, okay, we do have another one, which is moment. Okay, for the particle there are only 3. Okay, uh, because the particle is only a dot one, without considering the geometry, without considering the distance. Okay, but for the rigid body we are using the distance as well. So if we have the distance, so we have the moment. Okay, so for the rigid body you will have 6. Okay, not 6 actually, can be more. Okay, can be more. If you have the points, you will have more. Okay, all right. Okay, all right. Okay, all right. So the equation, Hussein, just now you asked about the equation. Yes, the equation can get it from this equilibrium. For example, the first equation. Okay, the first equation is from Fx equal to 0. Okay, the first equation. The second equation, f y equal to 0. The third equation, fz equal to 0. The fourth one, the fifth one, and the number 6 equation. Okay, this is what I mean for the equation. So if you have 6 unknowns, okay, you have to determine the 6 equation from this equilibrium system. Okay, so if you have 2 unknowns, so you have to determine 2 equations. Okay. The example later on, I will explain more about the equation, the number equation that you will establish. Okay, this is only a recap. Okay, a recap procedure to draw the FBD. Okay, procedure for drawing the FBD. Okay, so again, let's recap together. The first thing, you draw boundary, the geometry. Okay, chosen section, detach, separate it from other bodies. Okay, you choose only one. Okay, or you have to draw the overall system, for example. Okay, some cases you only can use one section. to get the solution. In some cases, you have to use overall system. Okay, it is depend on the situation. It is depend on the problem. It is very subjective. Okay, you have to determine by yourself based on your understanding. Okay, number two, for body with mass, yes, of course, you have to put weight, okay, gravity, and it should be downward, okay, vertically downward. And the next one is external forces, okay, acting on the body. If you have the forces that acting on the body from the external sources, then you have to put the force, okay. If the cable, you have to put a tension, okay, and outwards of the body. Okay, and the next one, put reaction. The other thing that you will learn in this lecture. Okay, you have to determine reaction. Where is the body touches connected with other rigid body in the system, and don't forget to put the dimension, because we are taking the moment. Okay, let's continue. Okay, this is the thing that you will learn. Okay, rational support and connection. A force with a known line of action involving one unknown. Okay, for this case, there is only one unknown. Okay, as I said to you in the previous slide, better not memorize, better to understand. So you have to understand the system, not memorize the reaction. No need to memorize. I don't memorize. I understand. Okay, so in order to determine, you have to understand the system. Let's say this is the first one. Okay, it is a ball that touch the floor, for example. Okay, you can see, you can determine. Let's say I'm considering one rigid body, which is the ball, in this case, which is the ball. Okay, with the external force from this second rigid body. Okay, the second rigid body push the ball on the wall. Okay, push the ball on the wall. Okay, from here we can determine the reaction. How many reaction, which direction. Okay, so again, you have to understand the DOF, degree of freedom. How many freedom the ball can go, how many direction the ball can go. Is it right, left, up, down? Okay, so in this case, how many? Anyone? Anyone? Lama tak panggil nama ni. Panggil nama lah, sedap lah. Adrina Patricia. Ada tak ni?
Yes, Dr. I'm here.
Okay. My question, how many DOF for this system? For ball system? Banyak ni. How many? Apa tu?
Bukan satu je ke, Doktor?
Eh,
Isn't it one?
no, the one is restriction. DOF is the thing that the ball can move. DOF, degree.
Oh.
Lama, bateri nak habis
Oh,
lah.
doctor, it can go everywhere except down.
Yes.
Yes, correct. Sekejap Kenapa problem ni? Let me do something. There is some technical error. Oh, bateri nak habis je. Macam mana nak buat ni? Wait, give me one minute. Kenapa tak hilang? Okay, give me 1 minute to settle this technical issue. Okay, great. So this is the thing that, yes, great from you. The system can go anywhere without one. There is only one restriction at there. Okay, the system can go anywhere. Let's say I'm doing this arrow lah. This axis lah. Okay, we do have X, Y, and Z. Okay, this one. Okay, the ball can go X direction. The ball can go Z direction. okay, the ball can lift up. This one can, this one can, this one can, and the ball can rotate. Okay, rotate at let's say I put it moment X. The ball can rotate at Z, and also the ball can rotate at Y. Okay. And the thing that the ball cannot go is only this direction, which is on the floor. This one cannot because it's
Perpendicular.
on the floor. Sorry? So in this case, the DOF is 5. Okay. Remember, this is 3D. 3D. So the maximum DOF is 6 for 3D. Okay, 6 for 3D. But for 2D, okay, the maximum one, if I considering the axis for 2D, the maximum one is, okay, 3 lah. Okay, moment X and Y. Okay, if I considering the axis, if I consider the direction, more than that lah. Upward 1, right 2, left 3, 4 if the downward moment is number 5. Okay, if I considering the direction, if I considering the axis and the moment, there's only 3 lah, 3 D or F. Okay. Okay, for the 3D, if I considering X, Y, Z axis only, the maximum D or F should be 6. Okay, 6. Okay, so in this case, the DOF is 5. So the restriction, okay, the restriction is on the Y axis, okay, which is the ball cannot go down. So if cannot go down, meaning that we do have a reaction that oppose back reaction.
The reaction will be upward.
Yes, and the reaction, this one should be upward, like this. Okay, not necessarily pointing to the point, but it can be from point to upward, like this. You can do like this as well. Okay, pointing like this. Doesn't matter. Doesn't matter. It is same actually. Okay, same. Same goes to the frictionless surface. The surface that very smooth, no friction at all. Okay, so there is only one restriction where the body cannot go down, Okay, so this is the one unknown. Okay, understand, right? Easy, right? Okay, this is another one. Okay, two force components. Okay, with two unknowns. Okay, so don't read the statement yet. Understand the figure first. Okay, so we have this roller. Okay, the roller only can go the roller X and Y and Z. Okay, let we determine which direction the roller can go. Okay, the Z direction, this one can go or not?
It can go.
Yes. This direction X can go or not?
No.
Cannot, right? This direction Y can go or not? Okay, no. They can go up, but cannot
Yeah.
go.
Yeah.
Okay, they can go up, but cannot go down. Okay, the cannot one, I call it cannot one, is the restriction, is the reaction. Okay, so in this case, okay, I'm not finished yet. This one is only a direction, not rotation. So if rotation is actually the roller can rotate in any direction. Okay? So there is no restriction for the roller to rotate. So meaning that no reaction. Okay. Let me erase to explain about the rotation or moment. Okay. Okay, this is the axis. That's Y and Z. Hilang pula. Okay, X, Y, and Z. So this roller can rotate. If the roller is rotating this way, okay, let me using the other color. Okay, this rotation like this, for example. Okay, rotation. It can go. Okay, it can rotate. Okay, if this direction, meaning that this one moment X, okay, can go, can rotate. Okay, if this direction, which is the the Z direction, which is this one, okay, sorry, the Z direction, yeah, it also can rotate, yeah, can rotate as well. And the Y direction, this one, okay, moment Y, it also can be rotating. Okay, so there is no rotation at all. So the restriction is only for the X and Y component. So meaning that we do have a reaction at Y and the reaction at X. Two unknowns. Okay, two unknowns. Same goes to wheel on rail. Okay, same goes to wheel on rail. Okay, they cannot go this direction. X direction cannot. Can go up, but cannot go down. So restriction on X and Y. Sorry, X and Y. Okay, there is only two restriction. So meaning
But
that
doctor, they can't rotate, right?
yeah, they can rotate. Yeah, they can rotate this way and this way. Yeah, and rotate pusing macam ni. Maybe I can use this one. Tissue container. Macam mana tunjuk ni? Gitu Nampak? Okay. So it can rotate like this. Following to the rail. On the rail, it can rotate like this. Okay, it can rotate like this. Can you imagine? Can you imagine?
Yes, Doctor.
It can rotate like this. I rotating this container. It can rotate like this. And also it can rotate like this. So there is no restriction. There is no restriction. Okay. Because of what? The wheel is not inside the wheel. Okay, it is only touch. Okay, it is only touch. If the wheel inside the wheel, so the rotation is the restriction. Okay. So far, any question before I proceed?
No, Doctor.
Okay, no, right? Very easy, very easy. Okay, very easy. Okay, next one, where the three unknowns involved. Okay. The first one is the rough surface. Okay, the previous one is the smooth surface. Frictionless surface. Okay, without any friction at all. Without the friction. So the rigid body can go anywhere. Let's say the floor, they can go anywhere. Okay, except going down. But if the system is in rough surface, meaning that we do have the reaction, okay, reaction, okay. So for rough surface, okay, of course, they cannot go X and Y in direction. They cannot go X, Y, X, Y, Z direction. Okay, this one, this one, this one. X, Y, and Z, they cannot go. Cannot go X direction, cannot, because of the friction. Okay, cannot go Z because of the friction. Cannot go down. This system can go up, but cannot go down. Okay, so meaning that only restriction, there is restriction as well. Okay, so the axis is the The movement on the axis is the restriction. How about the moment? How about the rotation? How about the rotation? Oops. Is the rigid body can rotate?
Yes, doctor.
Yes, because the body is only touch the surface. The touch. It can rotate like this. It can rotate like this. Okay, this is your rigid body. My pen is the rigid body. My other hand is the floor. Okay, I put the pen on the floor. I put the rigid body on the floor. You cannot go this way because of the restriction. I cannot move this way, but I can rotate like this. I can rotate like this. I can rotate any direction that I like. So there is no restriction on rotation, meaning that no reaction. Okay, the thing that cannot move, cannot rotate, cannot move, meaning that we do have reaction. So reaction is only on the forces, not moment. Okay, so this is the reaction for this system. Same goes to ball and socket. Okay, the ball and socket, the pen can move like this. Okay, can move this way, 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 and this way, but cannot go up, cannot go down, cannot go left, right, like this. Okay, because of the socket attached on the floor. Okay, right. Any question? No, right? So no question, go to more complex one. Okay, involving four unknowns, okay, so in this case, you have to imagine lah. Never mind, I will show you on how to imagine. Okay, sekejap macam dah nak habis bateri lah. Sempat kot sempat insyaAllah. Okay, so okay, so in this system, universal joint, for example, okay, like in our body, like elbow lah, our elbow here, you can rotate like this, elbow, you can rotate like this. This is elbow joint, for example, universal joint, elbow joint, okay. So you have this system, this one, okay. Let's say the number one, I put number one, number two, okay. This hand, if you can see on the screen, right side is the number two, okay, number two, okay. Number one is the left side, okay. So if I fix like this, okay, the number one I fix forever and ever like this, okay, like this, for example, like this, okay, we fix. So number two is attached to number one like this. Okay, you can see the number two cannot go up, cannot go left, cannot go anywhere in any direction because of the restriction of number one. But for rotation, there are some possibilities of rotation like this one. Okay, okay, like this.
Doctor,
Yeah.
yesterday you told us about the assignment.
Yeah, after this, not in the class. I will tell you about the assignment after the class in the WhatsApp group. Okay.
Okay, doctor,
I don't want to disturb. I don't want to disturb class hour. Okay. All right. So let me repeat. Okay, this one. Okay, this one. Okay. The left one is the number one. Okay. So if you can see number two here, it can be rotating like this. Okay, it can be rotating like this. Okay, it can be rotating like this, but cannot rotate like this. The cannot one is the x direction that shown in the slide. Okay, the rotation can be like this, can be like this, but cannot this cannot. Okay, because of the restriction. Okay, So that's why there is only one restriction for the moment. Okay, there is one restriction for the moment. Do you clear about this one, guys? Do you clear?
Yes, Doctor, very simple.
Okay, so let me explain on the screen. Okay, this one, this purple rigid body, okay, cannot rotate this way, cannot, but this way can be rotating. They can go up like this. For example, I draw like this lah. Can go this way, which is okay, this direction can go, which is moment z, okay, and also moment y can go, okay, but for the fx, this one cannot. So that's why there is one restriction for the moment, which is fmx. Okay, this is the last one, I think. Oh, no. Sorry. Alhamdulillah. Okay, this is the last one. Sorry, not the last one. Okay, the component, the system that having all restriction, where the body, the rigid body is fixed on the support inside the floor, for example, this floor. So the rigid body cannot go anywhere, like a beam in our house. The beam cannot go up, down, right, left, cannot rotate because it's strong. Okay, so there are 6 reactions where 6 unknowns involved. Very complex one. And I believe this one is not last lah, banyak lagi punya. Okay, let me try to finish before 10. Okay. Alright, this one, if the system having this kind of bearing supporting, there are 4 unknowns. Okay, there are 4 unknowns. Okay, this rod can be rotating this way, but cannot this way, okay, they can rotating like this, okay, but cannot this way, okay, cannot this way. So that's why we have a moment here. Okay, the body of the cylinder cannot go this way, cannot rotate like this one. Okay, cannot. Okay, and of course, let me erase this one. For the direction of x, y, and z, this cylinder can move this way. Okay, this way. But this cylinder cannot go this way, cannot, and cannot go up and down. Okay, so that's why Fy, Fz is there. Okay, all right. Okay, let me do quickly. Okay, pin and bracket, I think this is straightforward. The only thing that the only DOF is only one, okay, which is the pin, sorry, the rigid body. I call it rigid body here, can only rotating this direction only. Moment x can be rotating like this. The other direction, the other forces cannot. Okay, so that's why we have this one. Okay, it cannot go left, right, up, down, cannot rotate in other way. Okay, this one cannot rotate like this, cannot. Okay, cannot rotate like this one, cannot. Okay, and of course in direction, this one cannot, and cannot. Okay, same goes to this system, hinge, and also bearing, supporting, edge thrust, and radial loads. Okay, all right, I think that's it. for the reaction. Basically, I have to remind again, don't memorize, but please understand. Okay, you no need to memorize, but you have to understand the system. Okay. All right. Okay. So this is the last slide for today. The important notes for you. Okay. As I mentioned, FPD must be drawn for every solution. Okay. You have to draw FPD for every single solution, every single problem. Okay. To make the easy way to make the solution. Okay. To understand the moment, for example. Okay. Number 2. Okay. Knowledge on determination of force component, reaction, and cross and dot product for taking moment are essential. Okay. Yes, forces component, reaction is the important one. Okay. How many reaction involved in this system? What kind of direction? How many direction that involved in the system for the reaction? Okay. And then cross and dot product. Okay. Which one we want to use? Is it cross or dot product for taking moment? Okay, make sure that moment you are calculating is using cross product for the 3D. Okay, 3D cross product R cross F. Okay, and then okay, since there are 6 equations, they can be up to 6 unknown. Okay, for problem with more unknown, solve using moment about an axis. Okay. Okay, the thing that we just know is a moment about this as this. Okay, you can solve it about as this. And another way is you can solve the moment about a point. Okay, about a point. Let's say yeah, I make it simplified like this. For example, you can choose a moment about point like this. Okay, it is depend on the situation. We will go through the exercise, the example, maybe in next class. Okay, all right, thank you so very much. I think that's all for today. I really that some of you have a class after this. Okay, so thank you. If you have any question, just let me know right now, or maybe in the WhatsApp group. Okay, we can discuss together in WhatsApp. Don't someone personal message me, but I think the best way to discuss the solution in the WhatsApp group, because some student can help you. Okay. All right. Any question? Okay. If no question, thank you so very much. See you on Wednesday.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Thank you, Doctor.